Hello everyone. So this is a question from RE-NEET 2026. Consider the following reaction and choose the correct option. So we have toluene and some sets of reagents and we are getting P. So there are a few options regarding P and the chapters involved is aldehydes, ketones and carboxylic acid and amines. Okay. So in the given reaction we are starting with toluene. So this guy is toluene, which is reacted with a solution of chromyl chloride. CrO2Cl2 is chromyl chloride in CS2. CS2 is carbon disulfide, so this is the solvent. That is, you can see these are the first set of conditions. Under these conditions, toluene gets oxidized to a brown colored chromium complex having the formula. So I will remove P. So under the first set of condition, we get benzene ring, CHO, CrCl2OH and OCrCl2OH. Okay, so this is the brown colored chromium complex. Okay, when this guy is subjected to acidic hydrolysis, that is the second condition, H3O plus, then we ultimately get benzaldehyde, CHO. Okay, so this is our benzaldehyde. So this is our P. Okay, and this is the famous Itard reaction. This whole reaction is Itard reaction, and it is a method of preparation of aromatic aldehydes. That is, in the end we get aromatic aldehydes from aromatic hydrocarbons. So we started with the aromatic hydrocarbon toluene. Okay, so let's look into the options one by one. Option 1 says compound P is obtained by the hydrogenation of benzoyl chloride with palladium on barium sulfate. Okay, so benzoyl chloride is this guy. So this is an acid example of acid chloride. And when we do its hydrogenation, that is we react this guy with hydrogen, that is we pass hydrogen gas through it in presence of palladium catalyst supported over barium sulfate. Okay, that is this. That is with respect to reactions, we have benzoyl chloride, hydrogen, and palladium supported over barium sulfate. We get benzaldehyde, which is our P in this question, plus HCl. Okay, so therefore we obtain P, and this is the famous Rosenmund reduction reaction. So therefore 1 is a correct statement. Now coming to the second option, which says that on treating compound P with saturated NaHCO3 solution, brisk effervescence is observed. Okay, so it's an incorrect statement because P is benzaldehyde, which is an aldehyde, and aldehydes don't react with NaHCO3. Aldehydes don't react with NaHCO3. NaHCO3 is also known as sodium bicarbonate or sodium hydrogen carbonate. Okay, so the reason is this guy is basic. Okay, but aldehydes are not acidic enough. So these guys are not acidic enough. Therefore, no acid base reaction, or so they don't react with each other to give us the typical acid base reactions, or evolution of CO2, that is effervescence, takes place. So they don't react at all. Extra information, it's carboxylic acids that produce effervescence when treated with NHCO3 solution. Okay, so it's actually carboxylic acid that produce effervescence when treated with NaHCO3 because they are acidic enough. Okay, for example, CH3COOH. When we react this guy with NaHCO3, obviously we'll get salt CH3COONA plus H2O plus CO2. So this CO2 liberated produces the effervescence or vigorous bubbling. Okay, so therefore 2 is a incorrect statement. Coming to the third option. Third option says compound P can be prepared by treating benzene with anhydrous AlCl3 and CH3COCl. Okay, so benzene, when treated with anhydrous AlCl3 and CH3COCl, so this guy is also known as acetyl chloride, we get acetophenone. Okay, that is, with respect to the reaction, if we start with benzene and we react it with acetyl chloride CH3 double bond OCl in the presence of anhydrous AlCl3, we will get benzene ring and C double bond O CH3. So this is our acetophenone, and also HCl is the side product. Okay, so this reaction is the famous Friedel-Crafts acylation reaction. Okay, Friedel-Crafts acylation reaction. As you can see, an acyl group is introduced in the benzene ring. Okay, so therefore 3 is an incorrect statement, because when we react benzene with acetyl chloride, we get acetophenone, which is a ketone. We don't get P. P is a aldehyde, aromatic aldehyde. Okay, now coming to option 4. On treatment with bromine water, compound P gives a white precipitate. Okay, so due to presence of hydrogen atom on the carbonyl group, which can be converted into OH group without breaking any other bond. That is, in aldehydes, we have a H atom on the carbonyl group, or you can say H atom attached to the carbonyl group. This can be broken easily, and we can convert this H into, in the presence of oxidizing agents, into a OH group. Okay, and for this particular conversion, that is H to OH, we don't have to break any CC bond. Just breaking a CH bond is enough, which is easier. Okay, so therefore aldehydes are oxidized by even weak oxidizing agents like bromine water. Okay, because of this, because of the presence of this hydrogen. Important point. So due to presence of H atom next to carbonyl carbon, aldehydes are oxidized by weak oxidizing agents like bromine water. Okay, and with respect to reactions in general, aldehydes will react with bromine water to give us carboxylic acids. So they are oxidized to carboxylic acids and side product HBr. Okay, so in our case we have benzaldehyde. So upon oxidation we'll be getting benzoic acid and obviously HBr in the presence of bromine water. Okay, and none of the products are white precipitate. Okay, so therefore fourth is also incorrect. Okay, so fourth statement is also incorrect. Extra information: it's actually aniline that reacts with bromine water to give a white precipitate of 2,4,6 tribromoaniline. Very important. Okay, so it's actually aniline that reacts with bromine water to give a white PPT of 2,4,6 tribromoaniline. 2,4,6 tribromoaniline. With respect to reactions, I can write aniline as NH2 plus Br2. I will get NH2, and all the ortho para positions are occupied by bromine, and HBr is the side product, and to balance it, 3 and 3. Okay, so this is the white precipitate 2,4,6 tribromoaniline. Okay, so therefore fourth is the correct option. So finally the correct answer is, so they are asking the correct option, so 1 is the only correct option. Okay, thank you.